All right. Hello, everyone, and welcome to day 3 of Wisconsin Salt Awareness Week. Today's speakers are Amy Barrio, Public Information Officer with Madison Water Utility, and Kevin Masarek, who's a groundwater specialist with UW Extension. Amy and Kevin will be speaking about the infiltration of road salts and other salts into our groundwater in Wisconsin, which for most Wisconsinites is also our drinking water. After their presentations, Amy and Kevin will be happy to answer any questions that you have, so you can type those in to the live stream chat as they're talking, and then I'll moderate those questions. Before Amy takes the virtual stage here, I do want to give a big SaltWise shout out to all of the individuals that have signed up for tomorrow's Property Managers Smart Salting Training. So we're really excited to see the energy and enthusiasm for increased awareness and education around really right-sizing our salt use. We do have a few extra spaces available for that training, so if you're interested, you can email me and get a little bit more information about that. With that, I will turn it over to Amy.
Thank you, and thank you so much for having me here to talk about road salt and drinking water. I have a few pictures I'm going to show, so I'm going to share my screen here, and I'm going to pull up this presentation in theory. There you go. So this is basically what the inside of one of the City of Madison's salt barns looks like. We have a few of these across the city, and this is where we come to get salt during the winter. This is a little perspective, somebody standing inside a salt barn. In a typical winter, this will be refilled 2 or 3 times. This salt goes on the major roads in Madison, but there's another component to the salt we use, and that is on parking lots, sidewalks, and driveways. As much as half of the salt used in Madison during the winter is actually spread on parking lots and sidewalks and driveways. Where the water utility comes into all this, I work at Madison Water Utility, is that our water source is actually below our feet. It is a geological formation, a sandstone aquifer. This is a chunk of it that I'm holding here in this picture. So basically, you go hundreds of feet down below, where I'm sitting right now, all across Wisconsin, there's this massive sandstone aquifer, and in between those grains of sandstone is water. So what we do, this is a historic picture from Madison Water Utility, is we drill down until we hit that sandstone. This is a picture of a pump test at what was at that time a brand new well facility in the city of Madison. And we pump the water out of the ground using big motorized pumps at about 2,000 gallons a minute. So what we do is we try to make sure that once we have that borehole into the ground, we'll be able to pull up enough water for the city to use, especially when it comes to fighting fires. This is about 80 years later. This is our newest well in Madison. It's the pump test for well 31 on the southeast side. Again, drilled that hole down until we reach that sandstone aquifer, and then it's kind of like a straw. You suck the water up using pumps. It takes a lot of energy, about 8 tons a minute, and we make sure that the flow is there. Then we build a whole facility around it, hook up the piping, and then you don't see the water again, but this is basically what's happening at 23 wells all across the city. The problem is, because our drinking water comes from the ground, any pollutants that get put on the ground have the potential to make their way into our drinking water. And the pollutant that gets put all over the ground, all across the city of Madison, is road salt. Road salt loves water. When it hits the snow or the ice and melts it, it basically becomes dissolved, it becomes a solution. And that salty water can go anywhere that regular water goes. So into our lakes, our streams, our stormwater, and our groundwater. The groundwater is what we're talking about when we talk about drinking water in Madison. I actually took these photos. They're not far, probably, I'd say a half mile from a well that we have on Whitney Way. The photo on the right was particularly a sad one for me to take because this is on a sidewalk that is underneath, it's covered. This is next to a building. There is no snow or ice that's ever going to get to this part of the sidewalk, and it was heavily, heavily salted. And I, of course, went in and said something about it to the folks in that shopping center. So when we talk about salt, and I apologize if my photo is kind of covering up this little section of my presentation, but it's basically two chemicals that we're talking about, sodium and chloride. I wonder if I can move this. Yep. Sodium and chloride are the two components of salt. The EPA does not regulate either one of those under the Safe Drinking Water Act because neither are considered to be threats to human health. But it's that chloride that makes things taste salty. So when we look at the impact of salt in drinking water, we're measuring that chloride. We can follow it all the way along into streams, lakes, and groundwater. We're measuring chloride to measure that impact of salt. The EPA has set up an aesthetic guideline for chloride of 250 milligrams per liter. So basically what the EPA is saying is, once you get up to that 250 threshold, you're going to start to taste a saltiness in that water. The higher over that you go, the more salty the water is going to taste. So again, it's an aesthetic guideline. There's nothing that would prevent us from putting out water that's over 250 milligrams per liter in terms of salt, but it's definitely something that we are aware of. When we look at salt infiltration in the city of Madison, well 14 is a well on the west side. We're seeing it exceeding the EPA guideline for chloride sometime in the next 15 years. Another couple of wells on the west side in the next 40 years. And then we have 2 wells on the east side in the next 60 years. So 5 of our 23 wells are starting to show some impact from that salt that we've been putting on the ground. I want to take a closer look at 2 of those wells. Well 16 is on the west side. It's on Mineral Point Road, which is a really busy road. It's very close to Westtown Mall, a shopping center that's got a lot of parking lot around it. And you can see that when we've been measuring the chloride here over the last 20 years, we are definitely on pace. We don't really see a lowering of the chlorides that we're seeing in that well, on pace to at least get halfway to 250 sometime in the next several years. Well 14 is even more dramatic. So well 14 is located on University Avenue. It is right at the entrance to the Spring Harbor neighborhood, and it was built in the 1960s. It has been showing levels of salt infiltration that are really, really concerning. If we look at this well, and you've probably driven past it many, many times on University Avenue and never really even noticed it, it's right at kind of that entrance to Spring Harbor. It supplies 800 million gallons of water to the city of Madison on the west side every year. It is a really critical well for us. 140 tons of salt are spread on University Avenue between Allen Drive and Seago Road. So that's a 2-mile stretch. I believe it's maintained by the county. This well is also located near the Spring Harbor stormwater outlet. So I'd say it's probably a 1/4 mile or less from that outlet. That stormwater system takes all of the stormwater from really most of the west side of Madison, Westtown Mall, Hilldale, just this huge part of Madison, and it empties out into Lake Mendota right there. In the wintertime, that stormwater is full of dissolved salt. So this well is, is what we would consider to be past the point where we're going to be able to see those chloride levels go down. There's so much salt in the groundwater here. There's salt so nearby in that stormwater outlet. It's a heavily salted street. We are so close to that 250 milligrams per liter aesthetic guideline that we do believe we will reach that. The alternatives are not good. It is hard to get salt out of water. It takes something like reverse osmosis to get it out. Well, reverse osmosis, when you're talking about 8 tons of water a minute, is extremely energy intensive and expensive, and wastewater. This is a relatively small facility in terms of its footprint. You can bet it would be an enormous facility if we had to put in a reverse osmosis system here. Not only that, we could, maybe try to lower the casing in our borehole and pull water from lower in the aquifer, what we call our lower aquifer. The problem with that is we'll have some naturally occurring contaminants coming from the rocks in that lower aquifer: iron, manganese, potentially radium. So these would be other kinds of contaminants that we would have to treat for. Again, it's not like a Brita filter. When we're talking about the major volume, 2,000 gallons of water a minute coming out of this well, it's going to be very expensive, a huge facility on this footprint. So we're talking about millions of dollars that could potentially be invested on this spot just to deal with the infiltration of road salt into the drinking water. We don't want people to start to reject the water here because it tastes salty. And one thing I really want to point out is that this is a problem that we have created for ourselves. So, we want to see that bare pavement. We want to see that salt down, sometimes used as traction instead of an ice melt. We want to be able to drive fast down University Avenue, Mineral Point, Beltline. These kinds of expectations come with an environmental cost. This is not some far off problem. This is our own aquifer, one that provides our drinking water to the tune of 10 billion gallons a year. And when we fail to protect that aquifer, we end up with a situation like the one we're in now at well 14. And I could leave you with a lot of pictures of a lot of salt overuse, which I'm sure you've all seen, but this is what the right amount of salt looks like. It's space between those grains. It's not a, pile of salt to use for traction. It's not salt piled on top of snow. Shovel, spread that salt out. This is really all Wisconsin Salt Wise is asking for people to really be aware of the amount of salt they use, because it is a pollutant. It can pollute our groundwater, and we're seeing those impacts already. So I'm going to stop sharing my screen. And I am available for questions if you have any. Otherwise, I know Kevin has a lot of information as well.
Yeah, I think we'll have you put those questions into the chat, and then we can take questions for both Amy and Kevin at the end. There's a little delay here, Amy, so I think that's the best. And thank you so much for sharing. It's not necessarily the most uplifting story, but knowledge is power, and hopefully it's a motivating one. So with that, I'll turn it over to Kevin.
So thank you for the opportunity to participate in Salt Awareness Week here. Amy did a really great job of highlighting some of the challenges that municipal water systems are facing regarding chloride in their drinking water supplies. And I'd like to kind of give an overview of what we know about chloride more broadly in Wisconsin's groundwater statewide. And again, our groundwater resource, it's not an underground lake, it's not an underground river, it's just rain or snow melt that infiltrates into the ground and eventually reaches a point where all the empty spaces in the soil or all the empty or void spaces in the rock are filled with water. And that's our groundwater. It's always moving very slowly through those tiny spaces. It might be intercepted by a well. That could be a municipal well, it could be a private well. If it's not intercepted by a well, ultimately that water will find its way to a nearby lake, river, stream, or wetland. And I'm sure a lot of the previous speakers this week may have touched upon some of those things. Anything we do on the land surface does have the potential to impact the water quality below it. And I'd like to highlight maybe some of the other sources that we haven't talked about much up to this point, and help us understand the role or the extent to which those occur in our drinking water. Groundwater is, we refer to it as Wisconsin's buried treasure. Amy highlighted that Madison uses groundwater as its primary water supply. So do 95% of the other municipal water systems in the state of Wisconsin. Unless you live in a community along the Great Lakes, the chances are good that that municipal water system is using wells to supply water to its residents. 1/3 of all Wisconsin residents rely on private wells, so they are largely, unregulated well water supplies that people are using, oftentimes as their primary drinking water source. So that amounts to 75% of Wisconsin residents that are relying on groundwater for their daily water needs. Also important to point out, which we mentioned before, is that groundwater is connected to lakes, rivers, streams, and wetlands. So the map you see on the right, those areas in blue, those rivers and streams are more dependent on groundwater as a component of their total stream flow. And if you overlay where trout streams exist, you see a strong connection between that particular species of fish and in groundwater dominated systems. So not only are people kind of influenced by chloride in the water, but our aquatic organisms might be impacted as well, given the strong connection or export of things like chloride to surface waters in those systems. Amy touched upon that 250 milligram per liter aesthetic standard, which again, above that, it might give water kind of a salty taste. Increased levels of chloride may also increase corrosion of certain metals of household plumbing, particularly stainless steel is quite prone to pitting or corrosion at high levels of chloride. When we see, really high levels of chloride, we might also be concerned about increased levels of sodium levels or sodium concentrations in that water source. And sodium, especially for those people on really strict low sodium diets, that added level of sodium might be a concern. Greater than, or I should say less than 10 milligrams per liter is generally considered to be natural in much of Wisconsin. So if humans weren't here, if we weren't impacting the resource, we'd typically expect groundwater chloride levels to be less than 10. So when it gets above that, that's providing some indication that human activity is impacting that resource to some degree. When we look at various sources, we talked about de-icing, or Amy talked about de-icing using road salt previously. And again, that road salt running off directly from impervious areas into surface waters is a concern. But we also have to be concerned about that chloride that is highly leachable getting into the groundwater. So particular areas where that runoff accumulates and has a high potential to infiltrate, we know those are areas of high chloride inputs. It might be stormwater retention ponds, it might be road culverts. Those are areas of very concentrated chloride discharge. Agricultural activity also is a source of chloride. We use potash, which is mainly potassium chloride, to supply potassium to crops. But that chloride is largely unimpacted or uninfluenced by plant uptake. So that provides a mechanism for chloride from agricultural activity. Animal manure would contain some chloride. Human waste will contain chloride. Other biosolids that might be spread on the landscape would also release chloride to groundwater. And then septic systems, human waste would contain some chloride, but water softener salt is also another source. We use water softener salt to add, to regenerate a resin bed with sodium or potassium that is exchanged or helps remove calcium and magnesium from water sources to make it less hard. But that brine, a lot of that chloride is going to be discharged to drain fields. And we know that, areas with a lot of water softeners, those areas are going to be more likely to have elevated chloride as a result of that water softening process. And the map on the lower right just shows kind of areas where the water tends to be harder are located in blue. Those areas in northern Wisconsin that are kind of that light tan tend to have lower levels of hardness, where water softeners might be a little bit less common. But areas where we have hard water, again, water softener salt is going to represent another component of chloride discharge to groundwater. And then the last slide I have here is just showing what we know about chloride throughout Wisconsin. And much of that information comes from private wells that have tested their water. Chloride is not a very common test for private well owners to do because, again, there's no health-related concerns at levels we typically find in our water supplies. But UW Extension and UW Stevens Point have been offering kind of water testing programs over the last 30 years. And chloride is part of that general homeowner package that has been offered. So you can kind of see we've amassed a large amount of information over the years that help paint the picture of chloride throughout Wisconsin. And those areas where you don't see a lot of, where you see kind of the whitish color, those are areas where we don't have sufficient data to display kind of an average. But the areas in blue, those would be areas where we're at kind of background or natural levels. Those areas in green are areas where the concentration, average concentration is between 10 and 50. And then those areas in yellow and in orange and red are areas that are increasingly high with respect to chloride. What we know is that our lowest chloride areas are those with less urban development and less agricultural activity. When we see excessively high concentrations in a well or in certain parts of the state, a lot of times, as Amy alluded to, it's areas that we can link to maybe impervious runoff into a stormwater retention basin, maybe areas near major roadways or major intersections of roads or interstate. And those wells that are located in close proximity to those potential sources, occasionally we'll see levels in the hundreds or even the thousands of milligrams per liter of chloride. So we know based on testing that this can occur and does occur in various parts of the state of Wisconsin. And again, chloride provides a valuable tool for understanding the degree to which someone's well might be impacted by some of these various agricultural activities, septic system density, road salting activities, and those impacts on groundwater. Just in closing, there are some naturally saline groundwater deposits in some parts of the state of Wisconsin. So those areas are kind of highlighted in red here, where occasionally we do find, really high levels of naturally occurring chloride in groundwater that are due to kind of saline or brackish remnant groundwater deposits in the region. So I will leave it at that and turn it back over to Allison, who, if we have questions, I believe will help facilitate the Q&A.
Yes, thank you so much, Kevin. So we do have a few questions that have come in. I will read those off the chat, starting with the League of Wisconsin Municipalities. Has said, Amy and all, thanks for a great presentation. We did create this problem ourselves. What about liability issues?
Well, I assume that means that, businesses are worried about being liable for slip and falls in their parking lots. And that is an issue. That is part of the reason why, there's that kind of more salt is better attitude. All I can say is, I've heard about some states like New Hampshire have actually passed laws protecting folks who hire certified salt contractors, so people who have passed a state course in how to apply salt. And their legislature has passed laws that protect those businesses that hire those contractors from slip and fall liability. So that's something that we can look to as a possible solution.
I would also jump in there and say that a lot of the municipalities, the DOT even, different private companies that have worked with SaltWise have been able to reduce salt use by even 50 to 70% without negatively impacting public safety at all. Just the idea is that we've really been over salting, we've been over applying and gotten used to that. And we just want to kind of shift the norm and be more aware and mindful of putting down the amount of salt that's needed, not just more salt. So our next question here is from Kelly Thundercloud. Do all chloride compounds cause a salty taste in water when reaching a certain concentration threshold? And can these be detected in natural mineral springs via taste?
Well, I believe that, we get asked questions a lot about things like potassium chloride and other kinds of salt melts out there, but chloride is chloride. And so when we measure in drinking water, that's the chemical we measure, and it does carry a salty taste. Potassium chloride, I mean, I'm not advising you to eat it or put it on your food, but it can also taste salty and may also taste metallic and not so good in other ways. In terms of the springs, well, I can say Spring Harbor, for example, is named Spring Harbor because it has traditionally had these natural artesian springs. Those springs are springing up from the same aquifer, the same groundwater system that we pull groundwater from. So if there is chloride in the groundwater that we're pulling up, pumping our wells, it'll also be coming up in kind of those natural groundwater springs. But Kevin may have more insight into that too.
Yeah, I just add that we've done for educational activities some kind of water taste testing activities where we've used various bottled waters and had people try to detect differences between, let's say, municipal water and spring water, or there's a certain classification called mineral water, which I think, your Perrier's and some of the other brands might have specific mineral water. And if you compare mineral water to kind of, a typical groundwater sample from Wisconsin, some people can detect a slightly different taste, kind of a saltiness to it, because of the added minerals and other ions such as chloride that you'd have in that water. So if you're looking at, bottled water that's specifically labeled mineral water, you might actually be able to detect a slightly different taste because of the various ions, one of them being chloride in there.
All right, our next question is coming in from Eric Olson. Are cities required to address salt pollution in their municipal separate storm sewer system discharge permits? Is Madison, and how do they practically limit salt in stormwater?
I am not sure about stormwater. I know that the sewerage district has to meet or is supposed to meet requirements for chloride. That's where water softeners come in. The salt that recharges a water softener basically just goes down the sewer system and is released out into the environment because, as I mentioned, it's so hard to take it out. I'm not as sure about the permitting process around stormwater. As I mentioned, it's very, very, very difficult to take chloride out of drinking water, let alone stormwater. We can't really set up a treatment system at the end of a stormwater drain. It would be incredibly expensive.
Yeah, I would jump in there again and add that the Madison Metropolitan Sewerage District is one of the founding partners of Wisconsin Saltwise, and they have taken that role because it really is prohibitively expensive to remove salt from all of our wastewater. Like Amy said before, removing salt would be like doing reverse osmosis on all of our wastewater, and it would increase the rate users rates by like 500% in the Madison area. And the costs for that are largely energy costs. So the greenhouse gas requirements would go way up, and the sewage district's energy costs are already literally astronomical. So it's not really, unfortunately, practical to remove salt, whether that be the road salt that infiltrates through cracks in the sewer system or the water softener salt. And so the district is trying to educate, increase awareness so that we can have less salt inputs, fewer salt inputs. And then about the storm sewers, I would say that most municipalities that have storm sewers are guided through the DNR, through their MS4 permits, to do education and awareness around storm sewers and the fact that salts are going to travel with those through that water into our surface water. So that's kind of the goal, is to try to reduce those inputs, since we can't really catch the salt once it's in the water. All right, our next question here is coming in from Linnea Rock. And she said, thanks, Amy, Kevin, and Allison. Great presentations today. Are there any options for people who find out that their well water is contaminated by chloride?
That's a great question. And unfortunately, you know, Amy and Allison have talked about the challenges with treating for chloride. That negatively charged ion makes it, you know, the same reason it's very soluble through the soil and into groundwater are the same reasons it makes it really challenging to remove. It's very stable. There's not a lot of processes that are, you know, there's no processes that are going to degrade that chloride. And that, you know, those attributes make it really difficult from a treatment standpoint. If you wanted to treat your drinking water on a private well, reverse osmosis is kind of an option for private wells. It's incredibly energy intensive, so you wouldn't necessarily want to treat all the water in the home. But if you're talking about a few gallons per day for drinking water, reverse osmosis is an option for private well owners. That isn't an option necessarily for municipal water systems, though. So there are options. It's just, you know, ideally, I think we want to minimize the amount that ends up, just because of how challenging it is to remove.
Thank you, Kevin. All right, we've got a lot of questions coming in here. Our next is from Kay McKenzie. Are salt stockpiles kept away or protected from groundwater or lakes and streams? Are there any laws here?
That's a good question. You know, we don't always, I mean, we know where the city of Madison's salt stockpiles are. There's also a state or county, I think it's a DOT stockpile that's fairly close to our well 14. We've done some studies around that. We don't think that is responsible for the salt infiltration at that well. I'm fairly positive that there are laws around that, around storage of salt through the DNR. But you got to think about all the places that use salt. I mean, I got salt sitting in my garage. There's salt storage places all over. Probably every large, you know, facility has a salt storage area in it. So there are regulations and rules around that, but it's just a matter of kind of the enforcement of that, I would guess, is somewhat difficult.
Yeah, and I would say if you are someone who has the ability to control the storage of salt, just the simple step of covering salt piles can reduce the salt loss due to like wind and rain, snow on that salt. Without it being covered, we see salt losses around like 20 to 30% from those piles. That's just, you know, going to our water. All right, next question here comes from Matt. How much movement of chloride in groundwater is there? In short, even if Madison went salt zero, would the chloride concentration continue to rise due to neighboring communities using road salt?
You know, Kevin can probably also speak to this. In a sense, it's like, it depends, but really for our wells, it's relatively local. So we wouldn't expect a community, you know, further out into Dane County and its salt use to impact what's happening at one of our wells. Typically, the chloride that we see, if it comes from a far distance, is coming through the stormwater system. That's what's carrying it. It's not naturally coming through our aquifer that rapidly and that far. So it's either going to be stormwater retention ponds, or the actual, you know, putting down of salt on a major roadway near a well that's going to impact that well. So it's relatively localized, I would say.
And I'd just add that, yeah, we know, you know, depending on where you're accessing groundwater. Let's say it's a municipal well or a private well, or maybe the groundwater that's exported to rivers or streams. There is a lag time between what happens on the land surface and when that water might reach one of those particular features. So even if we were to stop kind of salting today, it might take years or decades to notice measurable improvements in some of the wells. Obviously, municipal wells are creating cones of depressions because they're pumping so much more water. So as Amy stated, it might be, you might notice those impacts much quicker. But a private well that's just kind of intercepting water along a flow path, or let's say a river or stream where there might be kind of a more widespread lag time occurring, it might take longer to be able to observe those benefits or those reductions.
Thank you. Yeah, I would say that the city of Madison, a number of the neighboring municipalities, as well as private companies that have been working with Saltwise over the last several years, have really made some significant reductions in road salt use. And we are seeing the concentrations of chloride in the Yahara lakes start to level off. But as Kevin and Amy said, there is that lag time between the salt that's already in the system, in the groundwater system, or on its way. I would say, Amy, maybe you could speak to this. Isn't there a map that's publicly available of kind of like the well 14 recharge zone? So like somebody wanted to look visually at like, salt in what area is going to impact this well, they could see that?
Yeah, there is. I'm not 100% sure where to send you to see that. But basically we have a wellhead protection plan for every single well. So it looks at the time of travel for, let's say, a contaminant on the surface when our well's in operation to reach our well. So there is certainly that for well 14. And one thing that I would add is that we do see, like for well 16, we can see a bad winter in terms of salt use versus a mild winter in terms of salt use. So we do see variability in the chloride levels. And I think, if we did stop using salt tomorrow on the west side of Madison, which is where that well is, then we would see it in chloride levels to some extent. There's certainly a lot already in the soil, already in the groundwater, but we would see some kind of a shift. I just don't know how big.
And I did just put into the chat the website that Amy and the City of Madison Water Utility has put up about well 14. And I believe the link is to that little map is on there. I just found it really interesting when I started this job in June, and I didn't notice it at all until, working for Saltwise, but you guys have put up signs around the well 14 kind of recharge zone that, say this is an important area and we should be aware of what's happening on the landscape here. But I think we tend to, drive by those signs on University Avenue without, really paying attention to that. So that's where Saltwise comes in. We're trying to help promote awareness. Kevin,
I would just add that even in certain private wells, private wells that might be really shallow and more easily influenced by land surface activities nearby. Occasionally we will, if they're sampled periodically or often enough, you will see kind of spikes, temporary spikes or seasonal spikes that would be related to maybe winter snowmelt from, let's say, a culvert or a stormwater retention pond. And there are, for those private well owners that might be located near parking lots or major roadways, measuring chloride or even something as simple as conductivity would give you an indication. If you suspected that it was influenced by road salt, it would give you some pretty simple tools to track during the year how those levels might be impacted by those activities.
Yeah, that's a good point, because at well 14 in particular, we see a difference depending on the season. And we go out there with the middle school kids from Spring Harbor Middle School and talk about chloride in their water at their school. They do those experiments out there in Spring Harbor, measuring the chloride even in the winter, and compare it to other times of the year. So you can really learn a lot just by doing measurements. Sorry, I have a cat. Doing measurements every so often to kind of see what those trends are. And that's what we're seeing at well 14.
Thank you. And I'm so glad to have both of you on together. It's fun to kind of see where you lead one another. Our next question that we have here is from Kay McKenzie. When snow is trucked away from roadsides in winter, there's been occasions where this is deposited near waterways. But it looks like she thinks some of these practices have stopped. So who looks at these practices? So the practices of snow being trucked away from roadsides in the winter.
I would guess the DNR. What do you think, Kevin? Is that?
Yeah, I'm gonna plead ignorance on this one. I'm afraid I'm not quite sure.
Yeah, my understanding also would be the DNR wastewater specialists. All right. So those are the only questions that I have right now. I'm going to give everybody just a little bit of time to process, because we are actually time traveling a little bit, and what they are listening to is us 30 seconds ago. So
Okay.
questions come in. But as I do that, I just want to say thank you again, Kevin and Amy. You are amazing experts in your field, both, and so well spoken. And we really appreciate the work that you are doing on behalf of Wisconsin Freshwater and all of us who depend on that water every day. So it looks like we are done with our questions for now.
Okay.
So you're off the hook. I know I took more than 30 minutes of your time today, but it was really appreciated. And yeah, happy Salt Awareness Week.
Thank you. And thank you for putting all this together and for all the work you're doing for Wisconsin Saltwise. It's really appreciated.
Thanks, Allison.
Bye.